Well, in this video, let us derive the joint distribution of XR and XS, the rth order statistic and the sth order statistic, right? R and S are such that 1 is less than or equal to R, less than or equal to S, less than or equal to N. What we emphasize here is R is less than or equal to X. And R can be anywhere between 1 and S, S can be anywhere between R and N. The joint distribution of these two variables, random variables, is derived as follows. FRS of x comma y is limit, see this delta x when it tends to 0 and delta y tends to 0. Probability of x less than or equal to xr less than or equal to x plus delta x comma y less than or equal to xs less than or equal to y plus delta y divided by delta x by delta y. When this delta x converges to 0, we get what is called the probability function. Let us call this numerator as the event E. Right? Now, I am going to describe the event by means of a line array. Okay? See, I have the first value here, the first order statistic x1, and this is my nth order statistic xn. And this rth order statistic is somewhere here, and the sth order statistic is somewhere here. Alright? This XR lies between x and x plus delta x. Between this interval, this very small interval, delta x is a very small number. Between this interval, only one value lies. And XS, the sth order statistic, lies between y and y plus delta y. Between these two values, only one value lies, right? Only one value lies. Now, up to this you have R values and one value lies here. So, how many values will be in this interval? Up to this you have R values and only one value is there in this interval. So, you have R minus 1 values here. And you just consider this first. Up to this you have S values. One value lies within this interval. So how many values will be there in this interval starting from x1 to y? You have S minus 1 values. If you go up to this, you have S values. One value is left out here. So you have S minus 1 values. Now, after doing this, you consider this interval. See, actually, you have S minus 1 values up to this. But when you consider this interval, the values up to this are left out. How many values are before this point? R minus 1 plus 1 is R. So, you have S minus 1 minus R. And you consider this part now. Up to this, right from the beginning, up to this n values are there, out of which up to this point, see, only one value lies within the small interval, and up to this you have S values, and after that no value exists. So it is n minus S. Okay. So the event E, I call this as the event E. The event E is described as follows. R minus 1 values, this is my first point, okay. R minus 1 values of xi are less than or equal to x. I am talking about this interval, right. R minus 1 values of xi are less than or equal to x. Okay. The second one is one value lies between x and x plus delta x. One value of xi lies between x and x plus delta x. Okay. And here S minus 1 minus R values lie between x plus delta x and y. S minus 1 minus R values lie between x plus delta x and y. and one value lies between. I am just explaining this line array, that's all. Okay, so one value lies between y and y plus delta y, and the last point is n minus s values lie between y plus delta y and xn. Okay, fine. So you have described the events here, and to make the process simple, let me call this probability as P1, this is P2, this is P3, and the probability for this event is P4, and this is P5. What is P1? P1 is probability that xi is less than or equal to x. What is it actually? F of x, right? And what is this P2? Probability that x is less than or equal to xi, less than or equal to x plus delta x. This is equal to f of x plus delta x minus f of x. Is it right? Your x is here, x plus delta x is here. You add all the probabilities from x1 to x plus delta x and reduce from x1 to x. Okay, so if you from this interval, if you reduce this interval, you will get this probability. Okay, for the probability for this interval, if it is reduced by the probability of this interval, you get the probability of this interval. That is the idea. Okay, so now P3. What is P3? Probability that x plus delta x is less than or equal to xi, less than or equal to y, which can be written as f of y minus f of x plus delta x. Okay, and here probability of y less than or equal to xi, less than or equal to y plus delta y can be written as f of y plus delta y minus f of y. And here probability that y plus delta y less than or equal to xi, less than or equal to xn can be written as f of xn minus f of y plus delta y. Fine. Okay, now what is f of xn? Xn means you are including all the values of the random variable x. So it is 1 minus f of y plus delta y. Okay, see what I mean is f of xn means probability that x is less than or equal to xn. All values of x are less than or equal to xn, so it becomes 1, right? This is the reason why I have written 1 here. Now let us start writing the probability function. Okay, I am going to let us number this as 1. I am going to replace this numerator by my findings here. Okay, so now 1 becomes, you are in need of what? FRS of x comma y. You call the density function of rth order statistic and sth order statistic as FRS of x comma y. Okay, that is equal to limit, let me start here. Okay, limit delta x tends to 0, delta y tends to 0, 1 by delta x delta y. I am going to define the numerator, which is the event E, and I understand that this E is nothing but E is a variable which follows multinomial distribution. Okay, some r minus 1 values are in this interval, 1 value is in this interval, s minus r minus 1 values are in this interval. So this is nothing but a multinomial distribution. Now probability of E will become, I know the probability function of a multinomial distribution, n factorial by r minus 1 factorial into 1 factorial into s minus 1 minus r factorial into 1 factorial into n minus s factorial into this power the number of occurrences, right? P1 power r minus 1 into P2 power 1 into P3 power s minus 1 minus r into P4 power 1 into P5 power n minus s. This is the probability function of multinomial distribution. Right, let me substitute. I know what are the values of P1, P2, P3, P4 and P5. I am going to substitute now. So this 1 factorial I can just leave. The answer for 1 factorial I know it is 1. Okay, fine. Now what is P1? Let me substitute. F of x power r minus 1. And what is P2? F of x plus delta x minus f of x power 1. What is P3? F of y minus f of x plus delta x power s minus 1 minus r. And what is P4? F of y plus delta y minus f of y power 1 into what is P5? 1 minus f of y plus delta y power what? N minus s. Okay. Now I am going to make use of this limit, right? And to facilitate it, see how I am writing. I am bringing all the constants outside. N factorial by r minus 1 factorial s minus 1 minus r factorial into n minus s factorial. Everything comes out. Now, see, I am going to apply the limits. Limit delta x tends to 0, delta y tends to 0. I have f of x power r minus 1, which does not contain any of the terms delta x or delta y. F of x plus delta x minus f of x by delta x. I am bringing this delta x here, okay, into f of y minus f of x plus delta x, the whole power s minus 1 minus r. I don't want to disturb. And the one delta y is remaining, right? I am going to write it along with this term. F of y plus, you know the reason, f of y plus delta y by minus f of y by delta y, the whole power 1 into, I am not going to disturb this term, f of y plus delta y the whole power n minus s. That's all. I am going to apply the limits now. When I apply the limit, what happens? Have a look at this. R minus 1 factorial, s minus 1 minus r factorial into n minus s factorial. Okay. I am going to apply the limits. So the first term remain the same. Here it becomes, this is nothing but when delta x goes to 0, this term becomes f dash of x. That is the definition of differentiation, right? F of x plus delta x minus f of x by delta x. If you increase x by delta x and compute the difference of this function in the numerator and divide the term by delta x, as delta x tends to 0, this is nothing but differentiation, f dash of x. And here you apply delta x goes to 0. So what will you get? F of y minus f of x. That's all. Delta x becomes 0. And here when delta y goes to 0, this becomes f dash of y. Okay. And here when delta y goes to 0, it becomes 1 minus f of y. Okay. Fine. So we can also stop here, but let us make one more step. Because we know when the CDF is differentiated, we get PDF, right? So this is the CDF of x. But what is f dash of x? It is f of x, small f of x, which is the PDF, okay? So f of y minus f of s, x power s minus 1 minus r, f dash of y becomes small f of y, okay? 1 minus f of y the whole power n minus s. This is the joint distribution of the rth order statistic and the sth order statistic, right?